All right, so today we're just focusing on the reactions of phenol and benzene, so aromatic chemistry. So this one is from 2018. So this is the portion of the 2018 paper that carried something to do with aromatic chemistry. So in this table, it's reaction of phenol. So they do the structure for phenol above. So the two reagents, so the two reagents, okay.
No, sir, excuse me. My mic now work on my computer. May I use my phone? I can't really see the top part of the board.
All right,
It kind
we're
of blurry.
here.
No, it's a
Blurry.
reaction with phenol. It blurry-ish.
So we have reagent, observation, and structure. So
All
three
right.
headings here. Reagent, observation, and structure. So here we have the reagents. So the two reagents we are using is aqueous bromine and sodium hydroxide. Right, so remember, and I remember what happened when bromine reacts with phenol. And so with bromine, do you know the product? Even if you don't remember the observation, remember bromine with phenol? All right, so when bromine reacts with phenol, so over here, we should have the expected structure. So we're going to get the product 2, 4, 6 tribromophenol. So whenever you have aqueous bromine with phenol, you will get 2,4,6 tribromophenol. Right? Now, 2,4,6 tribromophenol, it is a white precipitate. And it will also generate an antiseptic smell. Right? And the bromine is decolorized. So these are the three observations that we would have. The bromine is decolorized, we get a white precipitate and an antiseptic smell. The structure is 2,4,6 tribromophenol. For this one on the paper, the observation portion was blocked out. So all we need to propose is a structure. Alright? So sodium hydroxide, remember last week where Sabrina had mentioned the NaOH. So it does, whether it's NaOH, so phenol, even though the sodium hydroxide, you will not get a reaction with the regular alcohol like ethanol, but phenol is more acidic, and so you will get a reaction with NaOH. So whether it's sodium metal, a reactive metal like sodium, or the base, sodium hydroxide, it will get a reaction. Mhm. So the hydrogen and the phenol, the hydrogen will be replaced with sodium. And so you get sodium phenoxide. Alright. So this is what happens when phenol reacts with sodium hydroxide. We good? Atene, you good? You can see the board nothing, or I'm read any part. You can type. Oh, no, it might not working. Oh, yes, sir. All right. I can erase now. Type yes if that's the case. If I can erase and do a next question. All right. Let's move to the next question now. This one. All right. So Joel, we are just done a reaction. So we are just working past paper today. So we are just done a question from 2018. It involves the reactions of phenol. So we have a table. They gave us the reagent, and we're supposed to put in the observation and the possible structure of the product that would be formed. So if you remember with aqueous bromine and phenol, you would get 2,4,6 tribromophenol. For observation, the bromine, it would be decolorized. You would get a white precipitate, which is the tribromophenol, and the antiseptic smell. With sodium hydroxide, you would get sodium phenoxide as the product. And this was from 2018. So we're about to move on to the next question. This one is from 2013. Again, it's a table. So with these questions, you just need to ensure that you remember the reactions, the reagents used, and the products that will be formed. All right. So it's just like before again. It's phenol. This time the table is a little different. Also, this one, it did not ask for any observation. It gave reagents, how much draw possible products. Right? The structure of the products. All right, so the first reagent, they did not give us the reagent, but they gave us the structure. All right, not 2018, this is from 2013. All right. So if the product is sodium phenoxide, what is the reagent that we would use? Which
Sodium
reagent?
hydroxide.
Right. Or you could use what else? Which reactive metal?
Sodium.
Right. So you can react it with sodium metal or sodium hydroxide solution. Right. And then they gave us the reagent for this one. The reagent is bromine, aqueous bromine. So what should be the structure? Or what is the name of the compound? when you have phenol with aqueous bromine,
The tribromophene.
right? Plus 2,4,6 tribromo-phenol. And then for the third one, so they gave us the asked for the reagent in this one, for the product in this one, and in this one, they want the reagent again. And the product, this is the product. So can you tell me what type of structure is this? What is it? Or what compound? This group right here, what is it?
Carboxylic acid.
Mm-hmm. All right, remember, this would be the carboxylic acid. When you wrap the carboxylic acid with a particular compound, remember, and you get a structure like this, remember it's an ester. So this link, the ester bond, right? So this would be an ester right there. So if you know that this is the phenol, right? Which is the alcohol portion. Just a second. So if you get an ester, this is an ester, right? So if you want to know which part is the alcohol and which part is the ester, we have C single bond O. Everything from this single bond O, everything, that part of it, that's the alcohol. And the C double bond O and beyond, that is the acid. So C is the single bond O and everything beyond it, that's the alcohol. So which portion of this would be the acid? Which part should we start from? Which carbon? This, 1, 2, 3, which one of them for the acid?
The first carbon.
Right. Because anywhere of the double bond O, that is where the carboxylic acid would start. So we will cut it right there. That means this part is the phenol, right? So that would have been the phenol with the OH group. And then on this side would have been the carboxylic acid, which would, when they would have combined to give you the ester. Right? So the carboxylic acid consists of 3 carbons, or it could be an acyl chloride. Right? So CH3, CH2, 3, double bond O, Cl. So it could be an acyl chloride, CH3, CH2, 3 Cl. I don't know, phenol reacts with acid chloride as well. Let me just try about that. So that's the one from 2013. Alright, so we have a piece more from 2013. So for this one, they gave me this structure. It's sodium phenoxide. So we know we need sodium hydroxide solution or the metal. But this 2,4,6 tribromophenol. So we know we need aqueous bromine. And this is an ester bond right there. So you could use an acid chloride or the carboxylic acid. All right, so the next one now, let's enjoy. All right, so they want the reagents and conditions used in steps 1, 2, and 3. Steps 1, 2, and 3. And that's 3 marks. And then they want the mechanism – So they want the mechanism for the reaction in step one, which is from benzene to nitrobenzene. All right, I'll just give a little time to process this. So 4 minutes. Just take a little time to process and then we'll work. All right, so what is happening in step one? What is the name of this reaction from benzene to nitrobenzene? Remember the name of it? All right, so from benzene to nitrobenzene, that's nitration of benzene. And so you would need concentrated nitric acid, concentrated sulfuric acid, temperature of 50 degrees Celsius. So the reagents of and condition for part one or step one, it's nitration of benzene, so we need nitric acid and sulfuric acid. And for step two, if you notice, the only thing different between this structure and this one is the addition of our bromine atom. So that would mean it's halogenation of benzene, right? So we are reacting it with bromine, right? And the catalyst is FeBr3. And for step three, the bromine is still there in both of the structures, but what has changed is the NO2 group to the NH2 group. So that is reduction. And so we use tin and HCl. Right? So it's benzene to nitrobenzene, that is nitration. Then nitrobenzene to the bromo nitrobenzene, so we're adding an halogen. So it's bromine and FeBr3. And then we are reducing the nitro group to the amine group. So we use tin and HCl.
Second repeat, step 3.
Step 3. All right, so this one, we're converting the NO2 group to the NH2 group. So that's reduction. And we use tin. The symbol for tin is SN. So it's tin and HCl. Alright. So step 1, it's nitration. Nitration, halogenation, and reduction. So those are the three reactions taking place. All right, ready again? So they want the mechanism for nitration. All right, so we know that occurs in two steps, as we did last week. So we know it will react with the nitronium ion. So the pi electron would attack the nitronium ion. Remember, this gets a positive charge because it has three bonds, so it's a carbocation. In the second step, remember this ion from this step, where just write the equation to generate the electrophile. So this ion will come back to remove a proton. And then these electrons between the carbon and the hydrogen will go back into the ring. And you will generate back your catalyst as well, which is sulfuric acid. All right, so the mechanism,
Sir,
yeah,
what's going on? A reaction of benzene will do?
the mechanism for nitration. So remember again, the one of the pi electrons, any one want to use, right? It attacks the nitronium ion. Remember when we say attack, we mean it have form a bond. So we're forming a is covalent bond between the benzene ring and the nitronium ion. So that's what's happening here. Because they break the double bond, positive charge here. Okay, can you make the mic? Yeah. So you break the double bond here, so that means this carbon don't have 4 bonds anymore, it have 3 bonds. Bear in mind that we are not showing the hydrogens, so you have to remember that hydrogens are present. So this has 3 bonds, that is why it has the positive charge. Right? And then this ion will come back to remove a proton, and the electrons go back into the ring, so you generate it back, and you get back your catalyst here. So that's just the 2 steps for the mechanism.
So what's the name of this mechanism?
Nitration of benzene.
Alright, okay, sir.
Italic ox.
Yes, sir.
Alright. Alright, so continuing same 2013. So after they had asked us to write the mechanism for that one, it says state the reaction mechanism outlined in B2. So B2, it was going from, alright, I can erase this now. Alright, let me know when you finish. Alright. Right, so just to remind you, step 2, it was nitrobenzene, so NO2, nitrobenzene to this. So the only thing we did was added a halogen, which is bromine. So it says take the reaction mechanism outlined in P2. The name of the reaction is halogenation of benzene, but the reaction mechanism is not halogenation, is electrophilic, electrophilic aromatic substitution. Electrophilic aromatic substitution. All right, that's the mechanism. For step 2, explain why the bromo substituent occupies its position on the molecule. So I'm not sure if you remember, or if you were here last week, but remember now, the benzene group Alright. Position number 2 on the benzene ring, it's alpha. Alright. Position number 3 is metal. Position 1 and so position 1 and 4 is designated para, but something is always going to be on the ring. So position 4 is para. Again, for benzene, or so. For benzene, you can count clockwise and you can count anti-clockwise. So if this is carbon number 1, then this carbon and this carbon would be number 2. Because if you count this direction, this is 2. If you're coming in this direction, it's also 2. That means these are the metal positions, and this is the para position. So the NO2 group now is a deactivating group. And last week we said that deactivating groups, they are meta directors. That means if you're adding something to the benzene ring, once you have a meta directing group on the ring, it is going to go to the meta position. So the NO2 group is a deactivating group, and deactivating groups are meta directors. So once you have NO2 on the ring and they're adding something else, it will direct it to the meta position. So the question that asked, let's see one. Explain, all right, let me write it on the board. It has asked us to explain to, for step 2. All right, so while the bromo substituent occupies its position on the molecule, all right? So bromo, where it is, the bromo substituent, bromo substituent is in the meta position, all right? The NO2 group, the NO2 group is a deactivating group, and a meta director. Right, so the reason why bromine is here, this is a deactivating group and a meta director. So it directed the bromine group towards the meta position. So that is why it is there. Let me know when I can erase it. Still on 2013. We did this one last week, but I'm going to work it again. All right, so the table was part B. The reaction scheme that we just did, it was part B. Now this is part C. So it wants us to arrange benzene, nitrobenzene, and methylbenzene in order of increasing ease of moving. That's one mark. All right, so how do we know which one is more reactive? Benzene, nitrobenzene, or methyl benzene. All right, benzene is going to be in the middle, so it's going to be nitrobenzene, then benzene, then methyl benzene. Okay, and just draw an arrow and put increase in reactivity. So nitrobenzene is the least reactive. The reason for that, the nitro group is a deactivating group. It pulls electrons from the ring, all right? So it will make the benzene ring less reactive, all right? So that is why nitrobenzene is less reactive than benzene. This nitro group is a deactivating group, all right? We went through this in detail in the last class. Right? The methyl benzene, however, the methyl group, unlike the nitro group, it is an activating group, and we also say it is an electron releasing group. Right? So, because methyl benzene, it's an activating group and an electron releasing group, it makes the benzene ring more reactive. So methyl benzene is more reactive than benzene because it releases electrons to the ring. Nitrobenzene, it does the opposite. It pulls electrons from the ring, so it makes it less reactive. So it's nitrobenzene, benzene, and methyl benzene. And then for part two, for each reaction, draw the major, mono substituted product. Alright, so we have nitrobenzene, we have nitrobenzene on the nitro group, we have benzene, and we have methyl benzene. Alright, we are going to put the chlorine atom on each of them. Right? It asks you for the major mono-substituted product. So when we're adding groups to benzene ring that already has a group on it, it can all of the groups, it can go in the meta position, auto position, and para position. So even when you have a deactivating group, which is a meta directing group, you will get a small percentage in the alpha and para position. But the major product is the meta one, right? The one in the meta position. The methyl group is an activating group, and so the activating groups are alpha para directors. So for this one, the major substituted product is the chlorine atom in the meta position. NO2 is a deactivating group and the meta directing group. So it will direct the chlorine atom to the meta position. Now with this, during is empty, there is no direction, so you can put the chlorine where you want. Alright? There is nothing directing it to auto para anywhere. But this, as I said, it's alpha para director, so you can put it in the auto position or in the para position. Alright? And that's it. And it says mono 1, so you cannot put on alpha and para. So even though this is an alpha para director, you put it in the auto position or the para. It says major mono, meaning 1. Alright? So you either go auto or para. And that's it for 3 marks. So this was very 3 marks. So that's pretty easy 3 marks. And that was the end of the 2013 question. But just to make a note of something.
I don't like talking to me.
And this man, they never have this.
Oh,
German, that's something I got right down here. So. Right, so remember we did this one from part same 2013. All right, number 4A, we did it earlier, where we had to write which reagent would react with phenol to give you this product, right? I remember we said this was an ester, so this portion over here is the phenol, and this portion, with an ester, it can be carboxylic, it would be carboxylic acid and alcohol, or an acid chloride. But for phenol, it's just the acid chloride. So this portion here, it's not a carboxylic acid, it's just acid chloride. All right. So for phenol, it's just the acid chloride that we will use for this reaction. All right. So you can just make a note. So you can let me know when to move on. So repeat. All right. So earlier I had were you here? But yes, you were here. So remember in the table for part A, remember with the phenol with bromine and sodium, right? So I'm saying for part the third product, this right here, the ester, right? So I'm saying the reagent is the acyl chloride. Not I said acyl chloride, or you can put the carboxylic acid. Alright? But I just double checked, but the carboxylic acid, it wouldn't work. Just the acyl chloride. Understand now? So for this one, it's just the acyl chloride. The acid, the carboxylic acid here. Alright. Alright, so moving on to the next question. You finish right, nothing. So this question is from O9, the new one. Right, as I said, most of these questions, and as you can see, it's just knowing the reagents and the products. All right, so here we are going to start with benzene again. All right, so that's what we have. Benzene, intermediate, phenylamine. For the first question, draw the structural formula for the intermediate X. So you have benzene here. So what can benzene produce that you can react it with to get an amine? This reaction scheme is familiar. Anybody remember it? So benzene to something, that's something to phenylamine. All right, if you don't remember, it's nitrobenzene. All right, all right, NO2. So remember, benzene to nitrobenzene to phenylamine. All right, that's a common reaction pathway. Benzene, nitrobenzene, phenylamine. All right, so that's the structure of intermediate X. State the conditions required for stage one. So from benzene to nitrobenzene, what is the just the condition? It does not ask for the reagent. But still, tell me the reagent and the condition. So for step one, what is the reagent? It's nitration of benzene. So what is used for the nitration of benzene? What do you change class? Let me see what Nathaniel typed. Nitric acid, yes, and concentrate. So concentrated nitric acid and concentrated sulfuric acid. Reagent, the condition is the temperature of 50 degrees Celsius. So this is for step one, the reagent and condition. By the way, what is the name of the reaction for step one?
Nitration.
Right, nitration. So the reagent required for stage two. So what's the reagent required for this second step? So the reaction occurring here is reduction. And by the remember, so what is used for the reduction of nitrobenzene, tin and concentrated HCl, correct? Again, so tin and concentrated HCl. All right, so that's that. And this is from '09. For aromatic chemistry, as long as you remember your reagents, conditions, and the products, of course, you should not have a problem. All right. So next question. This was part A. Let me know when I can erase part A. Is anyone still writing? All right, part C. Part B is for next area that we will look at separately. And so part C, we have phenylamine. We have intermediate Y. Intermediate Y will react with phenol. All right, so the question is, write the formula of the intermediate Y. So phenylamine is this compound that you will react with phenol to give you an azodide. Which compound can we react with phenol to give an azodide? And that compound is coming from an amine, diazonium salt, correct. So intermediate Y is a diazonium salt. So let me just put it there. So it's nitrogen, triple bond, nitrogen with a chlorine, a negative sign over the chlorine and a positive sign over the nitrogen atom attached to the benzene ring. Next, the name of it is called benzene. I'm just going to put the name down here. It's benzene diazonium chloride. So the name of this diazonium salt is benzene diazonium chloride. All right. So it's a diazonium salt, and the name of it, benzene diazonium chloride. All right. Yeah. So for stage 3, which is here, on the reagents and the conditions. So for stage 3, on the reagents and condition. So I can see at the top. You mean up here? Okay, no? Sorry, so we have phenylamine and the intermediate Y. You just um, for intermediate Y, it's nitrogen, triple bond, nitrogen Cl, right? This is compound Y. You can see it? All right. All right, so we know that if we are forming a diazonium salt, right, from phenylamine, we need nitrous acid and what else? Hydrochloric acid. All right. So the reagent, okay, let me just erase this first. All right. The thing about the salt there, so we need nitrous acid and HCl, but the nitrous acid is generated within the reaction. So we use sodium nitrite. The reaction between sodium nitrite and the HCl is what will generate the nitrous acid, which is HNO2. Alright, so in the reaction, they don't just add HNO2. The sodium nitrite and HCl is what is used in the reaction to generate the HNO2. Alright, so mention this the sodium nitrite as the reagent because the HNO2 is not added directly. Alright, it is generated in the reaction using the sodium nitrite and the HCl. Alright, so instead of using HNO2 and HCl for the reagent, put sodium nitrite and HCl. Because if we put HNO2, it would mean that we're adding the HNO2 directly, but we actually generate it within this solution. And we know that this occurs at very low temperatures, right? Below 5 degrees Celsius or less. Right? Let me just put back this as the amine. So when we're converting amines to a diazonium salt, we use the sodium nitrite and the HCl to generate the nitrous acid. The diazonium salt is unstable, so we keep it at very, very low temperatures. Right? Name the reagent used to dissolve phenol in stage 4. Alright, so let me put up the azide here. So in stage 4, we dissolve the phenol in sodium hydroxide. Alright, sorry, about stage 4. So it's sodium hydroxide with phenol. Alright, so we dissolve the sodium hydroxide. We dissolve the phenol in a solution of sodium hydroxide. Right? So that's for part 3 of the question. Right, let me just put it on the board. So it says state the reagent used to dissolve phenol. Right? That reagent is sodium hydroxide solution. And then it says state the color of azo dyes when phenol is used. So azo dyes are brightly colored compounds. So they tend to be orange or red. Alright? So azo dyes are azo compounds are brightly colored compounds, alright? Often orange or red. Can be yellow as well. Now, if you were here from the start of the class, you would realize that we are using these reagents over and over across different past papers. Alright? So again, just know your reagents and structures. And then the last one is from 2019, which we did in previous classes, but I'm going to work it here again. So when you're finished here, you let me know. By the way, what is the name of the reaction for step 4? What is the name of it? So step 3 and 4. It wasn't asked on the past paper, on this past paper, but it could be asked. All right. So what is the name of the reaction occurring at 3 and 4? Anybody know it? What is the name of it? All right. So for stage 3, um, are you finished writing? Let me know. Yes. Yes, it's a long word, the name of the reaction. All right, so for step three, right, it's a long word. It's diazotization. All right. So the process of forming a diazonium salt is diazotization. All right. And then for this, so the diazonium salt with phenol to form the other compound, it's called coupling. Right, so this is your diazonium salt. All right. You react it with phenol to give you your azodide. This is called a coupling reaction. Coupling. All right. So we are combining the phenol with the diazonium salt. All right. So the name of that reaction to form the azodide is coupling, and it's the diazonium salt with phenol. Diazotization is the formation of your diazonium salt, and it's phenylamine, right, with nitrous acid and HCl. But remember, to generate the nitrous acid, we use sodium nitrite. All right. And so the final question is 2019. So part C of the 2019 paper had something to do with benzene. All right, so once the reagent, right, write the reagent used in reactions 1, 2, and 3. Before we look at the reagent, tell me the name of the reaction that is occurring or the process. So from NO2 to NH2, what is the process? We did it earlier. It starts with R. So the name of the reaction occurring is which reaction?
Reduction.
Right. So this one is reduction. Which structure is this? Even though the past paper chose to put it like this, can you tell me which structure is it or which compound? So the N2Cl, it's this. So once you see this on the benzene ring, which compound is that? Starts with a D, we just did it.
So that's the diazonium.
Right. So it is a diazonium salt. So if they see N2Cl, they just didn't write out the bonds. So it's N2, as you can see, it's N2Cl, nitrogen with the positive charge, Cl with the negative charge. So they just chose to write it like this instead of showing the bonds. So once you see this structure, you know it's here, diazonium salt. Alright. And so the name of this reaction, as I said earlier, it is diazotization. Can you tell me what is occurring here? From the diazonium salt to this compound, or this compound, it's an azodide because we combine the phenol with the diazonium salt. So what is the name of this reaction where we combine phenol with the diazonium salt? It's called what? Start with C. Coupling. Alright. So first we have reduction, then diazotization, and then coupling. So for the reagents for reduction of the nitrobenzene to phenylamine, we know it's thin and concentrated HCl. And for diazotization, we know we use this sodium nitrate and HCl to generate our nitrous acid for the reaction. And then for that, for the coupling reaction, we know we will use phenol. Right? And we can mention sodium hydroxide. All right. And so these are our reagents. So it says state the class of compounds to which E belongs. So the class of compounds to which compound E belongs, it is an azo compound. So compound E is an azo compound. We still can say azodide. So we want to say azo compound or azodide. Alright, so it's an azodide. And they are used in the textile industry. So one use of it, they are used in the textile industry. And yeah, so that's it for the aromatic chemistry sessions. So these are the questions I found. Right. I do remember to look at 2016 and 17 to see if they had any. But I checked from 2015, from '09 to 2015 and 2019. But even if 2016 and 17 have it, you will know it will look similar to something like this because as you can see, the question they don't really change much. Just remember your reagents. It's very important that you know them. As you can see, they're always asking you for the reagents and the products. All right, so that's it for this session. Yes.